Hello, good evening, everyone. So, today we are going to look into Physics 102. So, and our main topic today is we're going to talk about the Coulomb's law and Gauss law. So, that is our main focus for this test tomorrow. But I will advise you to solve many calculations as you can, and I will still solve calculation for you this night. So now let's talk about the Coulomb's law under gravitational force. So if we are talking about the Coulomb's law today, we're going to define Coulomb's Coulomb's law Coulomb's law of gravitation. So these are the main topic that they will ask you tomorrow. So if you are being asked to define the Coulomb's law also state that the force state that state that the force the force between two points charge is directly proportional proportional to the product of charge to the product of charge, and inversely proportional proportional to the square root of distance between them. So these are what Coulomb's law state that. So if we are about to look into this now mathematically, so I'm going to derive this question correctly. So but I will use a reference. Like when we're talking about two charge, let me just say I have my Q1. Let me just say I have Q1 here. So this is a Q1. It's moving in this direction. I still have another Q2. This Q2 moving in this direction. So you have seen it now. So they say that you should calculate from distance. There is a distance that separates these two charges, and the distance is we use r to denote the distance. Sometime you can also use x to denote the distance. So depends on what you want to use for the distance. So now let's just state this Coulomb's law mathematically. So we have to state it mathematically. So we have mathematical expression mathematical expression mathematical expression mathematical expression of Coulomb's law. So you can say that they say that the force between two charges, that is F. I will write F. F is the force between two charges, is directly proportional. Is directly proportional to the product of the charge. So which means in this product of the charge we have Q1 and we also have what Q2. So the product of the charge we have Q1 and Q2. And inversely proportional to the square root of distance between them. That is inversely. We are talking about inversely. We are talking about inversely proportional to what? Square root of distance, which is 1 over what? R. We are talking about inversely. Inversely means what? 1 over R is inversely. So now we are going to derive this equation. If I have this, which is F inversely, we are talking about inversely, or we are talking about directly. Directly means equals to here. I will introduce my constant K, which is Q1 and what? Q2 here now. Then I will times it with the inverse proportional, which is times 1 all over R. But inverse square root, which means you are going to have square this. Square root of R, you will square this. So I have that my F is equals to, if I turn this now, I'm going to have K, Q1 and Q2 all over R square. This one is for the force under Coulomb's law. When we're talking about Coulomb's law, we're talking about force. But when we are talking about electrical field, so electrical field is different in his own way. That is, electrical field can be defined as the force per unit or charge. That is electrical field. But when we are talking about this Coulomb's law, it's different from electrical field. I will still express that for you, and we will still derive more formulas in these areas. So let's just talk about this. Let me just talk about all these terms we have here. So we have that our F here is equals to our force is F. Then our K here is the constant. K here is a constant, and is given as 9 times 10 raised to the power of 9. This is for K. So we have our R. Our R is the distance. Distance is the R. So now we have our Q1, which is our charge. Charge 1. Our first charge. We have our first charge. Then we still have our Q2. Our Q2. So let me just call this